Hello, ladies and gentlemen. This is the start of the adventure, and I will be starting this practical sessions with a roadmap. And that roadmap or curriculum that I would follow will be based on some books, which I can tell you it's very difficult to read for most of those who are not consistent, and it takes a lot of concentration to process what's in the books. But I'll do that for you. So my roadmap as a first session will be to refer this book, which is called Efficient Linux at the Command Line. And these skills that you are going to be learning that is part of this book is going to turn out to be lucrative in your job searches, in your day-to-day practices of your work life, and you will also feel confident to interact with tech stacks and make things very, very clear. And theories are all over, but when what happens practically is what it matters, and let's learn by doing things. So this is going to be the roadmap, and we're going to refer this book, and I will deliver you the book in the most easiest way possible. So as you can see, we have we're going to go through the core concept, talk about commands, shells, rerunning command, cruising the file systems, environments, and we'll how to process text files and some goodies, and this is just will be a talking point for me, and I will be teaching you something practically. So okay, let's start. So as the first thing, what we need to do is that, remember when we were talking about in the first session that we talked about servers, right? We said, okay, the computers, the servers, and the data centers. So how do we spin or come up with a Linux cluster, or let's say a node, for example, or server? When I talk about servers, node, or clusters, I'm pretty much clusters means group of servers, and when I'm talking about servers and computers, I'm basically talking about a unit of compute. In my reference, that is a compute node or a server. So I'll refer to it as a compute node or a server that is interchangeably. So my goal is right now is to tell you how to spin a cluster, or how to spin a compute node. A cluster means a bunch of servers, but I'll tell you how to spin a compute node. Okay. So what I just did is that I just logged into one of the cloud service providers, which is Linode, and which is acquired by Akamai. So all I'm going to do is that so in the olden days, we need to go ahead and spin, go to install physical hardware, go into the data centers and hook up the wires, hook up the network, and all that. All of that thing has made so easy now, which is it's just a matter of how you create your email accounts or how you sign up for a service. You can simply also go ahead and spin a compute node. It's a very easy task. So Linode is just the native name. Linode was the name of the company, and create Linode basically means create a server. Linode is not a technical term, but Linode has some relationship with some operating system core concepts, which we'll talk about later. But Linode pretty much here refers to as create a server, for instance, or create a computer node. So as you can see, I've already one of these servers running, and but I'm just going to show you how to create another node. So I'll just go there and I'll create a Linode and choose a distribution. In this case, as I told you, Linux has several variants, and on different type of the different architectures on which different type of operating system resides, and there are several flavors of Linux. Well, in our case, what are we going to do is that we will stick to some of the so let's go over to some of the variants. So as I told you in my earlier lecture, there are Debian class, and there's Fedora, Gentoo. I talked about Debian, didn't talk about Fedora, but Fedora is also one of the variants of Linux OS. And then we have Kali Linux, and Kali Linux is variants of Linux that comes with a lot of libraries that assist security engineers to do lots of analysis, malware inspections, and there are several tools that are part of this distribution. So if you're a security operations engineer or something, and you do a lot of malware engineering or some security operations exercises, this is a very good, or a researcher, Kali Linux is a good stack to go with. And then we have Slackware, Ubuntu is a Debian class or system, and then SUSE is also one of the variants or one of the types of Linux OS. So we're just going to go by Ubuntu here, and let's actually spin up CentOS version. So I'll go with the CentOS 7, and I'll take a region. So regions are basically the data centers, like where are this is going to be spin. So as I told you, the real estate, eventually this is going to be one of the compute instances. As you saw that server that I showed you earlier, it's going to be one of the virtual instances which will be lying in one of those data centers. That data center was a real estate that had a bunch of racks and a lot of computers, and one of these rack computers has like probably thousands of virtual machines or instances. So this is going to be using those resources, so this will be one of the instances there. So I'll just choose one of the locations, let's say Fremont, California, and we'll pick like a small. So as I told you, that these are the resources that are fundamental resources of a server. So we have CPU, shared CPU, high memory, and GPU. So GPU is you can think it's like a CPU on a steroid, or more that has more processing capabilities. We'll not really touch GPU. GPU is expensive, but we don't need dedicated CPU. Dedicated meaning it will be just dedicated to us. So these shared CPU means that we will be sharing a part of computer processing unit. CPU is actually in hardware. So this is going to be a virtualized instance, and we would need one of we'll just employ a shared CPU instead of going with a dedicated CPU. Dedicated CPU means like this kind of processing unit will be dedicated to you. The shared processing unit will be sharing resources among other tenants as well. Tenants are the customers who are sharing the cloud platform. So as you can see, this dashboard is a cloud platform dashboard, and there are several customers of Akamai that can spin these nodes. And if they're sharing shared CPU, meaning then it means that they will be sharing compute resources out of a server, and will not have a dedicated CPU. Dedicated CPU is expensive because all dedicated for your workloads, and also this is good if you are if you're doing a production, or if you're doing a large compute processing, or you have live customers on a system, and you need more reliability and more processing capability assurances, then it's better to go with dedicated CPU. But in our case, it's a learning class, so I'm just going to spin with 1 nano 1 GB plan, and so this is an hourly cost of it. So life becomes easy, and our goal is to learn constructs of the operating system, and pretty much all of these instances that you there will be no compromise. You'll still be interacting with a complete operating system, and but the resources on them are limited and shared, so that's why the prices are less. Okay, so and we are just going to enter a password temporarily. This password will be important to get into these machines, and these are root passwords. So just remember, don't share your root password with anybody, so it has to be confident. Okay, add an SSH key. I'll talk about this later. I don't want to touch it right now, but this is this piece here relates to authentication, how to get into your systems and all, which is another exercise that I will teach you. So attach a VLAN. A VLAN is virtual LAN, local area network. We'll talk about that later. We don't need to worry about that right now. And so that's it. Let's go ahead and spin our first Linode. Okay, so it's saying password does not meet requirements. So let's go ahead with some better password. So we'll do okay. So I think I'll tell you the most easiest way in order to, okay, instead of doing this, I really don't like passwords, but for the sake of goodness, I'm just going to explain. Okay, we need to put the password, but let me just inject some basics here. Let's see. Okay, so okay, let's go ahead and just create a node first. Okay, So looks like I have so you can see this life cycle of the cloud orchestration frame. This is called cloud compute orchestration dashboard here. So it's orchestrating, and it's spinning. It's actually preparing a server for you, and a server. This is called IP address. So this is called the interface for anybody to reach this machine. This is an address, IPv4 address, which is called IPv4 address and IPv6 address. So this is how you reach. You use some transport protocol to reach to these machines, and it's already defining you that this is few ways to connect. So that's an SSH transport, and this is the command. This is how you need to use in your and this is the command you need to use to access the machine. So right now the instance is running, so let's go ahead and try to connect. So here you go. So this is my shell. Let's see. So we have a shell ready, and you want to connect to this machine, and as I told you, this is the address and this is the command. So copy the command here and let's go with the shell and paste it here, and it's asking okay. So this basically, this means that you attempted. So this shell itself is called a client, and the client is talking to a server, which is this thing, this part, and that's his username, the user that created by on the host itself. So this is a highly privileged user and on this host, and now that I entered this command, the response came back from the server indicating that okay, it has a response, and it's saying that in order to authenticate, this is the fingerprint of the server, and it is asking you to make sure to validate that you really want to connect to this machine with this fingerprint, and the response that we have is yes. Now as soon as we do that, it will ask for the password. We'll ask for the password and enter the password. So guess what, I entered the password and I'm in, right? So that's the first step. I am in the machine, and few things you can do is that you check your ID, your root, and you can say okay, W command will tell you okay, who is the user, where is it connecting from, and this is my IP, this is the host, this is my location, and it's also, you can check a few other things like for example what type of resources are on this machine. So we go over all this, but pretty much this is saying that this is a pretty idle machine at this point. Even the CPU is shared, it's pretty much idle. As you can see, these are some of the metrics. So ID means what percentage of the system is idle, so you can see the idle. These metrics generally will be higher number if the system is busy. So I think that's the first lecture. I hope you understood all that, and we'll take it up we'll follow up in the other sessions to go over more details around this concept. So thank you very much, and stay tuned, and we'll keep on learning together.